Thank you, Dr. Caldeira and Dr. Newcomans. You both will each get the coveted cafe-side mug, which I'll put there for your drinking enjoyment. And now we'll take questions from the audience at the two mics in the back. And if you can address your question to either or both of our speakers, and then we'll alternate between the mics. Thanks.
Maybe I could just jump and say something before we get the questions. In that 25 years ago, I was working in a group, and the oil companies were giving money to run climate models for climate conditions 100 million years ago because they wanted to know where the upwelling zones were in the ocean, where the plankton was forming, so they could know where to look for oil. And so they were willing to trust the climate models 25 years ago when it would help them find oil. So
it's all position.
Yeah.
It's all position.
Okay.
So this is a question for both of you. Great talks, by the way. Thank you very much. So CO2 emissions cause two major catastrophic problems. One is climate disruption, as you talked about. The other is ocean acidification that you mentioned and mentioned briefly. The oceans are roughly 30% more acidic now than they have been historically for a long time back. These sorts of manipulations don't do anything about the ocean acidification problem. Can you comment on that?
Yeah.
Well, this is the expert. That's what he's working on.
Yeah, no, so actually the term ocean acidification in its modern context was first introduced in a paper that I published in 2003. And I, last year, spent 6 weeks on a coral reef studying effects of ocean acidification on coral reef. And so I think the answer is yes. I think basically the story is we need to transform our energy system and stop emitting CO2. The experiment we were doing was adding alkalinity, essentially an antacid, onto the reef to try to bring conditions closer back to what they were a few centuries ago and measure if the reef was growing faster. And so I think there are techniques like that that could be done locally, but I think doing it at more than the scale of a bay or a small enclosed area. So it might help with marine parks, but I think that the difference between physics and chemistry, that these approaches that we're describing are physics, and you can have one particle or one cloud droplet, and it can reflect billions and billions of photons. But anything that's chemical, for each molecule of CO2, you need another molecule to react with it, or you need to take that molecule out. And so there are just no big wins with chemistry in the same way that there are big wins in physics.
Are you aware of any other programs that are being done for either of these techniques internationally, either by governments or commercial, that are actually underway right now?
Well, there is Leslie Field here in the audience that's working on sort of trying to save the Arctic, and there are people that are trying to make all kind of bubbles essentially and all that kind of stuff. None of these programs are actually, the one that we're trying to raise money for is probably the first one that Leslie has done some small field experiments, but so we're doing a little larger scale.
In terms of governmentally funded research, all of it has been computer modeling and paper research and so on. And as far as I know, there's been no government funding of any hardware effort at all.
Well, there was a little effort in England, right? And so what they were actually doing is spraying water from a balloon. And this got around in the press. Well, actually, there were also some efforts to, put iron in the ocean, and that wasn't very well done. And so that's, you can't, by the London Convention, you can't dump anything in the ocean, including iron, which is a fertilizer. I should let you speak about it. You know all this.
But when I say there's no government funding, I meant for any of the solar, sunlight reflecting things. There's, except for computer modeling and paper studies.
Brian von Herzen from the Climate Foundation. I had I heard the observation that stratospheric aerosols could have the potential of decreasing direct sunlight by up to 45% and increasing indirect sunlight by up to 35%. This would seem to have a very significant effect on the concentrating solar power, tens of billions of dollars of investment, to potentially decrease their top line revenues by up to 40%. I was wondering if you could comment on that. And then secondly, we've been looking at stratospheric sulfates. Given that we know that tropospheric sulfates have such a significant effect as evidenced by the ship tracks, why not look at tropospheric sulfates as an alternative?
Two things. One, that just to get the numbers, after Mount Pinatubo, the direct radiation was reduced about 2%, but the indirect, about 20% of it came down scattered, which would reduce concentrating solar by around 20%. There are a number of other particles that, I'm not an expert in the aerosol radiation interaction, but there are other particles that have more backscattering and less forward scattering that, that could reduce that 20% to maybe 5% or something like that, but it would have a negative effect on concentrating solar. The reason why, there's something on the order, several million people a year die because of health effects of anthropogenic aerosol emissions. It's estimated to be something like on the order of 3 million people a year. And some of that, a lot of that is coal-fired power plants, some of that is stoves and that sort of thing. But the residence time of sulfur in the lower atmosphere is 5 days, and so you would need to have huge amounts of it, and I think the health impacts most people would regard as unacceptable. I think the reason why there's a mention of sulfur is that's what volcanoes do. There are other particles like carbon, made of carbon and other things that would have better properties that would probably be better in the long term, but just haven't been explored as much.
So with Mount Pinatubo, which put in 20 million ton or something like that, and so these guys are talking about 1 or 2 million ton in the beginning. So there was not a very large decrease in what you could see. You had this beautiful sunset, and you may want to check this, but the French, since a very long time in the Pyrenees, have had these concentrators, and it'd be very interesting to see if they really saw the effect. I find it very hard to believe that even 20% wouldn't be around. But that might be true.
I mean, I think one of the one of the issues with particles is there's an aggregation problem, and so one of the interests in sulfur is that it was introduced as a gas, SO2 in the case of a volcano could be H2S, and then the gas oxidizes to form particles of about the right size. When you put in something as a solid, you have to worry about how do you keep this stuff from clumping and all that. But I think the assumption would be that if it ever did get deployed, people would start looking for better, ways to reduce the forward scattering or reduce the. There are other particles that people are looking at that would actually increase ozone production, and so I think once it gets into designer particles, you're in a whole different world, I think.
Has anyone looked into creating useful stratospheric particles by mandating an additive to commercial jet aircraft fuel?
Yeah. Most jets don't fly high enough is the issue. The cost analyses just suggested that that a dedicated fleet of small planes would be the most cost-effective way to do it. And I think the main issue is that cost isn't the driver. It's really, is there risk reduction and damage reduction? And the costs of doing these things at the scale of the global economy is trivial.
It's $5 or $10 billion a year if you do this stratospheric. And David Keith gave a very interesting talk here at the Commonwealth. I wasn't there. You see how you would tailor this very gradually and how to do the experiment. It's frightfully easy to do. That's what really we all worried about.
Armand gave a more emotive talk than I did. But I just have to say that we have a paper submitted now that says if in a business as usual scenario we end up melting all of Antarctica. It takes thousands of years, but it's something like 200 feet of sea level rise, something 60, 70 meters. And we've done other work saying that with current emission trends that by mid-century, which is just 30, 40 years from now, basically no coral reef in the world will be sustainable. And so anyway, I think I did an article in Scientific American a couple of years ago, which basically said that this carbon went into the ground when the dinosaurs were around. Mm-hmm. And basically, we're putting that carbon that was in the atmosphere hundreds of millions of years ago back in the atmosphere. But this transition to the warm climate with inland seas of the dinosaurs, it took millions of years to develop that, and we're getting that in a few centuries. And so it's rates of change that are really unprecedented. Yes.
For Ken here, you've alluded to the political problems in the future. It would seem to me that you would have to have unanimity in all of the different countries to be able to do geoengineering. Can you comment on that?
Well, I think there's a question of what you, first of all, I'm a climate scientist, not a politician or whatever, but I think that I think there's what you would like and what the real world is like, which unfortunately is starkly contrasting. And that, unfortunately, I think it'd be good to have good governance systems and try to get as much international consensus and democratic input as possible. But I think, unfortunately, I think a possible counterexample of how things shouldn't work but often do work is something like the Iraq War, where you get a small group of powerful nations that basically people aren't willing to go up against, and then they go do something. And in the case of the Iraq War, it obviously proved to be unwise. And so, hopefully, but I think another example is, China right now is building airstrips in the South China Sea, filling in a coral reef. And basically nobody's willing to go and stop China, and Russia's going into, Russia's going to Ukraine. And so when you have powerful countries, you could like everybody to proceed in a consensual, democratic way, but often the world doesn't really work like that.
I think it's a challenge.
So
Yeah.
there are actually, there was a conference in Asilomar that tried to set guidelines for how we're going to do this. There was there was one in Oxford.
Yeah.
People sort of try to work this out. But if somebody decides to do it.
I think there is a disincentive of basically if somebody starts tinkering with the weather in a big way, any bad weather event that happens anywhere in the world, the person who's doing it is going to get blamed for it. And so I think there is a big political disincentive for doing it. But on the other hand, if you're in China and there's a massive famine, and you think you can save hundreds of millions of lives by putting a few percent of what you're putting into the atmosphere out of your power plants and just putting it higher, that it's hard to imagine a political leader saying, "Oh, I'd rather my people to die." So I think if things get bad enough, it's high. There'll be very strong incentive to do it.
There was sort of an incident like this, right? So who was it at General Electric? Langmuir. So they came up with this silver iodide, right? And so they were going to seed the first hurricane. And they were all set to go. And they seeded the first hurricane. So it was coming down, and all at once it took a 90-degree turn, which was unheard of. Now we understand that this was not because of the seeding, but that was the end of the seeding for a very long time. No more hurricane seeding. So, you deal with these very, very carefully. Of course, there are a lot more computation now that people can do and model this essentially. But you tread on this very, very carefully.
In the early part of the presentation, in early part of the presentation, you mentioned that we had a interesting combination of things. The stratosphere was cooling down and the earth was warming up. Mm-hmm. And this whole talk has been concentrated very well on how to keep the earth from cooling up. Could you please explain to me what are the mechanisms by which, the natural mechanisms by which the stratosphere has been cooling over all these millions of years?
Oh, the stratosphere cooling is something of the last decades as greenhouse gases as greenhouse gases increase in the atmosphere. And it turns out the mechanisms of the stratosphere cooling is not so simple to explain, but you can think that every greenhouse gas is, emits at the same wavelengths that it absorbs at. And in the stratosphere, the stratosphere gets hotter as you go higher up. That's why it's stratified, because it's thermally stratified. And in the but I'm saying in the stratosphere you have the higher CO2 concentration. I don't want to go. It's hard for me to reconstruct all the physics, but basically the net effect of CO2 in the lower atmosphere is that it's absorbing long-wave radiation that's at a higher temperature than what it's emitting at, and so it acts as a net absorber and releases its energy kinetically to its neighbors, whereas in the stratosphere, where the temperature profile is the opposite way, it's absorbing at colder temperature than it's emitting, and so in the stratosphere, the net effect of CO2 is to be a net emitter, and it helps radiation escape to space. I could kind of, I don't want to go through too much more detail.
So if I understand you right, you get a double benefit by cutting down carbon dioxide. The stratosphere, it allows the stratosphere to cool better, and it allows the Earth not to get warm.
Yeah, most people are worried about temperatures at the surface of the Earth. The stratospheric temperature is important for the ozone-destroying chemistry, but I don't think in itself people are very much concerned about stratospheric temperatures.
There are other clouds, the cirrus clouds, right? The very high clouds that basically trap infrared radiation and don't reflect very much sunlight. So people are sort of, very theoretically looking at this, what that would do.
Yeah, this is the low clouds, by whitening the Earth, have a cooling effect, but the high cirrus clouds have a warming effect because their cloud tops are so cold that they don't radiate much long-wave radiation to space. And so another idea is to try to reduce the amount of these high cirrus clouds and allow heat to escape more easily to the space. Yes? Oh, over here.
Hi. So I know multiple times you've mentioned that this is an application that can be applied anywhere. And I'm curious, as you've mentioned multiple times about Mount Pinatubo, have you done any research to compare those results to Mount St Helens and what kind of difference you would have at different latitudes?
Yeah, so Mount St Helens was pretty small compared to Mount Pinatubo. Mount St Helens really didn't have any big global scale climate effect. The ones that had big climate effects were El Chichon and in the early 80s, and then I think Agong or something like that in the early 60s. But Mount Pinatubo was really the biggest in the last century. So one of the contrasts between the marine cloud brightening and the stratospheric aerosols is that the winds in the stratosphere go around the entire Earth very rapidly, and there's really no way to keep the effect of stratospheric aerosols localized. And maybe you could put more in one hemisphere than another, or maybe you could weight it slightly latitudinally. But more or less, if you do the stratospheric aerosols, you're committed to doing global or at least hemispheric scale climate change, and not very sensitive to exactly where you put it in. Maybe the equator, putting it the equator versus the North Pole would make a difference.
Mount Tambora, of course, in 1815 was a huge explosion, and you had famine over most of Europe. You had famine here in the United States, frost in June, there were no crops, and so that was a prime example.
It would be more than people would. And in contrast, the marine cloud brightening is something that could potentially be done, say, off the coast of California. And and I think this is one of the intriguing things in that, again, the research hasn't been done, but it's possible that as Armand talked about there's a large fraction of the water that the redwoods get comes from the fog, and if that goes away, a lot of the redwoods would be threatened. And so this idea that, well, if you sprayed a fine seawater spray off the coast of California, it might help protect the redwoods. Also, it's possible that if you cool the ocean, that you increase the land-sea contrast, and a cool, moist sea breeze might come into the southwest. And if
Secondary effect.
yeah, right. And so so the people of Phoenix, if they're sweltering in the heat, this question, people think this is controversial and people won't like it, but if spraying seawater in the air helps to keep the desert Southwest cooler and moister, it might prove quite popular.
So you don't worry about the salt in there because every droplet that falls as rain has something in it, sulfate or sulfate. It's just salt. So.
I should also just repeat that everybody working on this is very conflicted because nobody likes these things. No, it's not. No, I don't think anybody in their right mind thinks these are good things to do. It's that there's a possibility that the alternative of not doing it could be worse. Yeah?
Brian von Herzen from the Climate Foundation. During the middle of the talk, you mentioned that the best solution would be one that actually pulled the CO2 back out of the atmosphere. And so the question I would have, well, by some estimates at NASA, primary productivity in the ocean could be down 20 to 40% due to stable stratification of the oceans and effectively climate disruption effects. I'm wondering if you've given any thought or heard about any work where attempts were made to restore primary productivity in the oceans and try to address the CO2 problem by helping nature do what it does best, and that is fix carbon.
Well, you and I sort of went over this before. Sort of make these big tubes with a big bell on it, and you bring out the thing, and I guess you did some experiments. So if you want to see what the going thinking is, the National Academy report had something on there. So I don't know about the
yeah, I mean, so there's two things. Yeah, so the basic thing that's happening is two things are happening. One is as the surface ocean warms, it's more stratified, and so that prevents nutrients from the deep ocean to mixing up to the surface where there's light. And so you could imagine different pipe techniques or different techniques to physically increase the mixing, and the people have proposed wave-driven pumps. The other thing is that the stratospheric, or either of these cases, by cooling the surface temperatures, would tend to decrease stratification. And then the last one that people have suggested is iron fertilization. One of the things is that the carbon thing, we've did some simulations where we fertilize the ocean to its maximum extent everywhere, and after about a century, on the time scale of a century, you've taken up something like 100 gigatons with iron fertilization, and which is like a gigaton a year, which is less than anyway, by the end of the century, it's a few percent of our emissions. And there's kind of a question: is it worth doing this much activity for a marginal effect? So I think the difference, again, it's the chemistry and physics. The physics has these huge multipliers that chemistry doesn't have.
One last question.
So it's just a question about showing my ignorance about stratospheric atmospheric dynamics. What you mentioned that the civilian air flight has been at an altitude which is really lower than what you consider the stratosphere. My question is, though, we have decades now of injection of material into the stratosphere, or the lower part of the stratosphere, from civilian air flights. What has been the impact? Has anybody looked specifically just at that, apart from what it does to just affect the overall CO2 content of the atmosphere? What is that? Has that had any specific impact on climate?
Yeah, when I was I used to work at Lawrence Livermore National Laboratory, and there was a group there that was focused mostly on, at one point there was a proposal to increase supersonic transport, and those planes flew higher and would have put a fair amount of material into the stratosphere and could have had substantial effects on the ozone layer. The primary climate effect, so I don't really know about the stratospheric effects of the current aviation, but there is some evidence that the contrails, by being high, are radiating. Basically, they prevent long wave or heat radiation from escaping to space and then radiate at a colder temperature, and so that the contrails have a small cooling influence on climate. But anyway, that's about as much as I can answer your question.
Okay, thank you very much.
All right. Thank you, sir. Good job. You did a great job.